let's look at example number 6. What we're going to do is go ahead and take a peek at the graph of this function either on Desmos or our graphing calculator and pick out some key points that we'll plot, and then we'll talk about increasing and decreasing intervals. Here we are on Desmos, and I have plotted my equation x to the third minus 3x squared plus 6. I notice that it has one place where it crosses the x-axis. Since it's a third degree function, that means I must have two zeros that are imaginary. Other key points, I can see that I have one of those turning points that's a local maximum at 0, 6, and I have a turning point that's a local minimum, a low point at 2, 2. 0, 6 also happens to be my y-intercept. So I'm going to use those points and the fact that my arrows are going would be down on the left and up on the right to go ahead and draw a sketch of my graph. The first thing I'm going to identify from my graph was my x-intercept. I only had one, even though this was a third degree function. That just means that two of my solutions are imaginary and I can't see them on my xy plane. It occurred at negative 1.2, 0, so I'm going to plot a point there. You can label these if you want, or if you feel like it's going to be too cluttered, you do have them labeled in your notes over here on the left. The next thing I'll identify is my local maximum. I had one local maximum, and that occurred at 0, 6, so I'm going to plot that point at 0, 6. And then I had a third point at my local minimum. My local minimum was at 2, 2. So that was the point where we kind of hit that point and then turned around and went back the other way. So I can go ahead and plot my graph based on those and the end conditions that I observed. I know that I was down here below the x-axis and then I came up at negative 1.2. I turned back around here, turned around another time, and then went up. So let's go ahead and talk about increasing and decreasing intervals. I am increasing as I read my graph left to right. I see that the first thing I come to is an arrow. That means it continues that direction. But I am going up, 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 up until I hit this point right here, my turning point, which is the local maximum. So I know that that is a critical location in my graph. So I'm going to go ahead and draw my dashed line. This is similar to how we did it when we were going the other direction back earlier in the chapter when we were given the intervals and we had to graph from that. So I know that my graph is increasing over here. And in fact, I could go ahead and draw an upwards arrow on that side. Now, I see that I'm going down, 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 down until I get to an x value of 2. So let's go ahead and plot another line at an x value of 2. And I know that between 0 and 2, I was decreasing, I was going down. And then finally, once I hit this turning point at 2, this local minimum, then I went up, 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 and I never turned around and went back down. So that means that I'm continuing to increase all the way to an x value of infinity. I will be at a y value of infinity as well. So let's go ahead and write that in words. So I have my increasing intervals. I have two of them. One of them is here, and the other one over here on the right here. My decreasing interval, I'm going down here. So let's first talk increasing interval. And I want to start with my increasing because that's where negative infinity is. I'm reading from left to right and I'm increasing first, starting at negative infinity and going until I get to 0. Once I hit 0, then leave yourself some space here. We're going to put another interval right here. I have a decreasing interval next, and that decreasing interval starts at an x value. Remember, all of these are x values, in between an x value of 0 and 2. So I am decreasing from 0 to 2. Now, I'm increasing again. So starting at 2, where my decreasing interval left off, and then I never turn back around to decrease, so that goes all the way to infinity. So notice that negative infinity to infinity, and then the spots in between 0 and 2 are my decreasing interval. So overall, I have covered everything from negative infinity to positive.